I promised you that we would be joined very soon by the head of environmental sustainability, Group Environmental Protection for Central Energy Management for Mercedes-Benz. And here she is, Jana Krägenbring-Noor. Great to have you with us. And Jana is going to talk to us about why circular systems are so important for the German car giant and its role in wider decarbonization processes. Jana, we can't wait to hear from you.
Yeah, thank you for introduction and thank you for having me. So I'll start with one slide like this, and I want to guide you through a little bit and come to the circular economy point. When we talk about decarbonization in our automotive industry, we have to look at the overall life cycle. And that is what we want to show you here on that slide. So we start with our supply chain. We already heard some words about that. So everything what we got provided from our suppliers. Then we have our own production and logistic processes. We have the well-to-tank perspective. That's basically the loading, or today the fueling, if we talk about combustion engines. Then we have the tank-to-wheel perspective. That's basically the driving phase itself and the end of life. When we, as automotive, think about decarbonization at all, we have to think about all of those life cycle phases. And when it comes to circular economy, and that's very important here, we just talk about more or less the supply chain, because this is the part where we talk about materials, the materials that we use in our cars. When you see those numbers here, and you can figure it out on the bottom of the slide, you see how big those portions are. And when you look down to that, you see that the biggest portion for now, if we talk about the portfolio structure we have now for more or less all OEMs in Europe, you see that the tank-to-wheel perspective, the portion here is the biggest level for decarbonization. So the first point is, when we talk about decarbonization, changing the portfolio. We describe that change of the portfolio in our so-called Climate Transition Action Plan. We developed that with some other big companies like Microsoft, like Unilever, and so forth. We write down how we're going to handle that in every life cycle phase here. I don't want to read you through here, but just to give you an idea how we handle that. And when we talk about energy itself, and you may remember my first slide, when we talk about energy itself, why it's so important to have the right energy in place, and why it's so important to talk as well about the efficiency, is because the amount of energy you use for the individual mobility is very, very good. If you talk about battery electric driven vehicles, you see here on that slide the electric equivalence, or more or less the electric efficiency that we can already with the cars today, or starting within the next year, that we can show already on the streets. So we have efficiency factors like 95 or like 93% already. And that's, of course, very, very important when you talk about energy transition, when you talk about the energy amount that is used here. So for decarbonization, circular economy, of course, is one, but of course also the energy efficiency. So the amount that you use for driving is very, very important. The numbers would be very, very different if we would talk about e-fuels. That's why the electric driven vehicle itself is, for the efficiency factor, the most valuable. And for the energy usage, talking about renewable energies and the availability of renewable energies is the way to go in the very long perspective. And there comes, of course, the next thing regarding the loading. So the way you handle the usage, what kind of energy you use for loading the car, makes the story round. Of course, for individual mobility needs to be renewable, so energy coming out of green sources. So comes, as I mentioned in the beginning, when we talk about circular economy, we talk about our supply chain. So make sure that, of course, the recyclability in the end of the car. I come to that in a minute, and then of course the usage of the secondary raw material, or let's say the usage of recyclates, is very important. And on the automotive point of view, we currently structure that as well regarding decarbonization. So you know that circular economy, recyclates, usage of recyclates are also a decarbonization measure in the end, so an enabler at least. And when we talk with our suppliers, and that's a big lever that we can use and that we already do, is how to handle and how to give targets to our suppliers as well. We said for Mercedes, we want to be net carbon neutral in 2039. That's our main target, with the reduction of more than 0.5% already within the end of this decade. And we give this target or this ambition to the suppliers as well. So we talk to them, and that's a topic in our awarding process, to make sure that the suppliers that deliver our parts for our cars are as well in that range, and are as well in that decarbonization pathway. So we have for every material in the end clear decarbonization targets by year, and that is something that we have in a discussion with our suppliers, and that's something that is part of our awarding process at all. And then for now, and I talked about this year, I talk about the year, the last year, we work with so-called lighthouses because it takes time. You heard that already with some speakers before myself. It takes time. It's not a digital from 0 to 1. It takes time. So you need to very slightly and very, step by step going forward with that. And we say, okay, we work over lighthouses, see if that works, see if the decarbonization works, see if the recyclate is working in our cars, and then going further down the road until 2030 and 2039. So putting that on the road, and I brought you some lighthouses here, especially for steel and aluminium. In that case, I come to the battery a little later. Steel and aluminium is still, and will be also for electric driven vehicles, will be the most important material that we use. And especially in steel, you do have a transformation of the steel sector itself as well. So again, we go over decarbonization and see the share of recyclate that we want to have in our cars, and the share of closing the loop parts in our cars as a strong enabler for decarbonize the material itself. We already work with a lot of suppliers. I mentioned here some on that slide, where we have decarbonization pathways defined, where we have lighthouses defined, where we already got delivered by lower carbon intensive steel, lower and carbon intensive aluminium, and up to 100% steel parts that have up to 100% recyclates as well already inside. So this is happening, and this is something that as an OEM, as automotive, you need to scroll down the supply chain at all, and then making partnerships with the suppliers to have exactly those closed loops. And again, this is step by step. That's not a digital thing in the end, right? Of course, you need to make sure that the car itself in the end is also recyclability. And if we talk about our recoverability, we already, and that's for all OEMs the same, on 95%. 85% are recyclable already. So to make sure that the car itself is possible to give this and on the overall the car, to give this in the a circle for having the recyclates in the end somewhere is already given. When it comes to the battery itself, we figured out, and that is 2 or 3 years ago, we figured out that the battery, when it comes to electric driven vehicle, is one main focus field for us. So we already build it up and we try to learn how to build up closed loop here as well, because the battery itself is a very valuable part in the car as well for the customer. So the price of a battery electric driven vehicle is a lot of driven by the battery price. So in future, it's very important to have here as well a good recycling rate and a good, recycling process, and to have that mostly in the closed loop. You see that here. What is the cycle? What does that cycle means? We have that here with some numbers to guide you through a little bit. Of course, it starts with the product design. We heard a little bit about that as well. So you need to have the overall part in a design that you can, recycle it, and that you may as well, before you recycle it, remanufacture it and repair it. Yeah. On the third, I want to highlight here some issues. On the third structure point here, of course, all the production itself needs to be net carbon neutral as well. So especially the cell production is very energy intensive, and you need to have here as well energies from renewable sources. And then I jump to the point number 5. You have, again, the possibility, and you need to design this as well into the cars, that you can refurbish it and that you can also, use other use cases. And that's basically point number 6, other use cases with those batteries. So the batteries have a high 80 kilowatt up to 100 kilowatt are the batteries that we use today for all cars. And of course, if you put them into a second life, if you have with them different use cases, like may also stationary energy storage possibilities, they can be used further on after they are not used anymore in the cars, because we do have some specification that they are not used when they are not able to charge more than 80% anymore. So what we did for the technology, and that is a really focus point here for us as well, is we need to have a different technology than we used so far. So recycling technology for batteries is so far very energy intensive as well, and it has high recovery rates as well today, but still there should be some more. So we have our own battery recycling plant. In the meantime, that's a pilot plant where we try to, more or less scrap the batteries, not chemical recycling way, and we already figured out, and you can see that on the right side here, that we have 96% recovery rate with all those materials that you can see down here in the blue line, which is basically the battery made out of, right? And with that, I would finish my presentation for you. May to have one additional comment on that. For overall, you need to have everywhere a key performance indicator that an engineer can use for it development of the car itself, of the parts of the car. And that's why we say always we want to increase the share of recycled materials in our cars, because that is so important, and that is something that the engineer can handle in the end. And that's why we go in our circular economy ways for the share of recycled materials. Thank you.